Hello, everyone. So I'm super happy to introduce you to our guest of honor today, Andrew Duchowski from Clemson US. So for those of you who don't know Andrew yet, Andrew is a so-called godfather of nowadays eye tracking. He's not the first godfather that existed, but he's in like third line of descendants. Am I right, Andrew?
Yeah,
please.
Pretty close. I should have brought my Best Godfather Award from Etra. It's hanging up there on my my bookcase.
Okay. Please, Andrew, tell us about yourself a bit. What do you do now? Yeah.
Sure. Very happy to be here. Thanks a lot for inviting me. I've been doing this for, I don't know, since 1998, I guess. And I started off in grad school and with eye tracking. And actually, I didn't know what I was going to study back then. But a friend of mine asked me whether I could look into, how an eye tracker worked. And so I contacted this company, iScan, and I got the brochure, and it looked interesting. That's how I started. But really, what appealed to me about it, and it still does, that's why I'm still very happy to be doing this, is that it requires all sorts of interesting components like computer vision, which drives a lot of the eye tracking, especially like mobile or even the webcam-based eye tracking. It requires psychology, the study of the human brain. And in fact, learning about eye movements, my advisor at the time said, Andy, do you know what drives eye movements? And I'm like, no. He said, well, you better go find out. So I went to the medical sciences library, and I actually really enjoyed reading neuroscience books. And so superior colliculus drives eye movement. So study of the brain is fascinating to me. Plus, besides computer vision, you need to do a little bit of computer graphics for visualization and control of the display. So that's kind of how I fell in love with it back in the late 90s. I've been doing it ever since.
So how was the typical eye tracker in 1998? How did it look like?
Brought it here. I could have showed it to you. I still have it. It was this rather large camera, and it was analog, believe it or not. And it was sitting on a pan tilt unit, so it would kind of rotate to follow your eyes around. And on the side of it, there was a. Do you remember the old? I forgot the term of it. It's not a slide projector, but it's the old.
I know. Like put the cassettes with the pictures and it just rolling.
No. This was when you were in school and you were writing on this kind of transparency projector.
Mm-hmm.
It would project to the screen. So they had these powerful bulbs in there, the light bulbs. And so this eye tracker had a big light bulb behind an infrared filter, and it would shine the light on your face, and then it would kind of track you when you moved. So it actually took up, half my lab space was these monitors and this eye tracker and the computer running all this. So that was back in the 90s. Okay.
Yeah, so a lot of things changed for sure in the eye tracking market since like 24 years ago.
Yeah, around, if you go down sort of history, in 2002, thereabouts, digital cameras really kind of made one leap forward. So Toby came along one year at Etra and just kind of leapfrogged everybody and said, hey, look, these cameras no longer require focusing, because that was a huge trade-off. The old one, you had to sit there and focus the camera per every individual, which was really annoying. But now with the table-mounted ones, they traded that off. So this one here, whoops, I'll shake my camera, but here's one table-mounted one, which actually, this is the gaze point, so you're familiar with that. RealEye works nicely with these guys. So this, it's got a set focal length, 50 centimeters or so, and that's the big trade-off with the digital camera with computer vision running. So all of that was one leap forward. I guess because of the pandemic and all that, webcam technology is the next area where things are taking off. So that's you guys pushing this forward, which is nice to see.
Thanks, and thanks for these words. Okay, so could you just tell us a bit more about your favorite project you did with eye tracking? Maybe it was something like with some psychological research, maybe something was used in some research that helped out, or it's too many of them to remember.
Yeah. This is a question I often get asked. What's the killer app?
Yes, exactly.
For eye tracking, and there isn't one. In fact, there's a lot of apps, a lot of projects going on, and so right now it's kind of, I guess, I'm doing again what I did back in 2000, which is kind of interesting. So right now, my an interesting project that I like is back in virtual reality. And so I started this in 2000 with a VR helmet and an eye tracker that these same guys that had the pan tilt unit, it was called IceCam, these guys, and Ricky Rasden was the fellow who was running it. I don't know if they still exist or not, but back then it was $60,000 is what it cost, and the guy promised he would build the eye tracker and that would work. And so I'm like, okay, here's the money. And 1 month goes by, 2 months goes by, and nothing. And so eventually they did build it, and it did work. And so it was maybe one of the first VR eye trackers. I don't know. But it worked, got some work done on it. And now it's really amazing because the helmets now have the eye tracker built in.
Right.
And they cost about $1,400. So, I mean, you could buy one for the home if you're so inclined and have the money and play games with it. And so that is, once again, kind of driving the field, just like it did 25 years ago, which is really fascinating.
What is the biggest advantage of having the eye tracking in the VR helmet? Is it just for as a user interface, part of the user interface, or it's also used for, I don't know, rendering stuff on the screen? What's the main goal of it?
Yeah, so the computer graphics people who are interested in this, foveated rendering was indeed one of the sort of drivers. And so because your vision is high acuity is limited to your size of your thumbnail at arm's length, there's no point in rendering at high fidelity everywhere else. And so computer graphics people got a hold of this, and they started doing foveated rendering. And so that's one of the reasons that's driving this. So you want to just render at high res in one area and then track your eyes and catch up. One huge problem there is that depending on the sampling rate, you're always behind the eyes, right? Even if you're sampling at 60 hertz, you're going to be 16 milliseconds behind. And so sometimes that high res foveal region is kind of laggy. You'll always kind of catch up. But one of the interesting research areas there is gaze prediction. And so you can actually do this mid-flight when the eye is in the middle and you're sampling fast enough. You could figure out, that's the peak velocity. So then you can mirror and expect where the eye is going to land.
Whoa. That's really cool. I haven't heard of it. Mm-hmm.
Yeah, so it's interesting because this goes back to, I brought these out just for fun. Going back sort of down memory lane, these guys actually had something similar to ETRA back in the 80s. So this is what Munty, Senders, these guys, and Fisher, I think is the last one. And they actually had in here, back in 1985 or something, they had a little article in here, chapter on how to do eye movement prediction. I don't know, nobody actually picked it up, or I don't know, for whatever reason.
Basically, based on the incoming saccade, they can decide whether this is going to be finished as a fixation somewhere else, or is it just the small saccadic eye movements? So there's like some thresholds of the eye velocity, or how does it work? Just out of curiosity, you got me here.
Yeah. If you're doing real time velocity estimation, like you can do with the just a simple filter, And if you kind of follow it in real time, you'll see the velocity will go up, it'll peak, and then it'll start dropping. Now, at that very instant, if you find the peak, then you can look back to see the amplitude and then mirror it, right? And so dotted line back here. Yeah, you could predict roughly based on that speed where the eye is going to land. This also has to do with the main sequence of saccades. A very classic work in that the eyes, even though it's kind of a non-linear system, saccades fall into this linear sort of predicted line. So it's something like 2.2 degrees plus 20 or something, which says that the degrees, if you're going to make a saccadic jump of 10 degrees, it'll be about 22 plus 20, whatever, 40 milliseconds. So based on those kinds of models, you can do a certain amount of prediction. And so there was a paper in SIGGRAPH SIGGRAPH 2017, something like that, where they did this, and they actually customized it. They made you do a bunch of saccades, so they would record your main sequence, and then they would predict where your eyes are going to go, and then they put in the foveated rendering in front of it, and it worked pretty nicely. So
nice.
I actually think that, in terms of where we're headed with eye tracking, it seems to me that the next kind of evolution is going to have to be some kind of real-time based analysis and more dynamics.
Mm-hmm.
We've been doing fixation analysis, fixation duration, Krzysz's Kreitz coefficient, the K coefficient.
We all should know it already from the previous interview.
Yeah, we all should know it already.
Go to our YouTube and check it.
Exactly. So those are all kind of offline measurements where we always do post facto and you can do nice diagnostic reports. But I think the next stage where we're going with this is real-time implementation of these kinds of metrics. Mm-hmm. And you can implement the K coefficient in real time. All you really need to do is figure out. Go on.
Yeah, we just had an internal discussions with Kasia and the team actually, and with Krzysztof about what could be the possible usage of implementing the K coefficient live in the matter of data analysis and data processing. And like of course, there are several use cases like watching. I don't know, if you're running a remote session in classes, you can see what's the, let's say, an average attention level for all of them. We were thinking about like several use cases like this, so also live.
Especially for webcam eye tracking. If you're in a classroom session and you can do this live, you can do possibly things like, are students paying attention or not, those kinds of things. So I think there's a lot of applications for this, and and all it boils down to is calculating, because if you want to put it in Krzysz's Z-scores, right, you just need the mean and the standard deviation, and the question is, well, how long of a past window do you use? And I don't know what the answer is. I've got a demo of this with the gaze point, where I just keep a running average since I start recording. But I don't know if that's useful. I think the next experiment that one should do is figure out what's the window, temporal window that you keep track of. Is it
can be adjustable? So, like that
could be adjustable. But then that would be the best to be
value?
adaptive, right?
Yeah, but of course we should propose a best value, just like for fixation filter settings. It's customizable, but the best idea is to run these and that numbers.
Exactly.
Okay,
and if you can make it adaptive, even better. Yeah.
We can do it. Okay, cool. Thanks for this. Actually, that was my next question. So, what are the next steps in the eye tracking? What are kind of like what's going to happen next? And my question in the middle actually was, what is happening right now and where is it happening? So are there any meetings, meetup, conferences? Where do you guys meet? Where do you figure out what's the next big thing in the tracking? For
me, just sort of what's on my brain is is a little bit of assistive stuff in VR, and so I'm working with Krzysz in a group in Barcelona and in England. Chris Salford, not Salford, he's at Salford. Chris Hughes is the guy's name. He used to work at the BBC, and Pilar Orero is this woman in translation studies in Barcelona, and we're looking at subtitles in VR. But I mean, subtitles on video would also be interesting to look at. And so, whether it's in VR or AR, I'm also interested in augmented reality. We have the, not Pupil Labs, but the Microsoft HoloLens also has a built-in eye tracker. It only samples at 30 hertz, but that's what I'm doing right now, is looking at assistive technology. And so we're gonna meet at the Venice Film Festival and see whether we can get various film production people interested in this kind of thing, in looking at eye tracking over subtitles. But like I say, you've got a potential here to do this with RealEye as well. If you want to watch the video with subtitles and see whether you can record RealEye eye movements over those, that would be interesting kind of thing to look at. But besides the Venice Film Festival, well, ETRA is the meeting where we meet for eye tracking research applications. It just happened in Seattle a couple of weeks ago. SIGCHI is a good one, even though it's much bigger, and so eye tracking research can get kind of lost there because there's so many other things going on. And I still would like to break into SIGGRAPH and do more work there. That is a huge conference on computer graphics. It's happening in Vancouver in a couple of weeks. I'm not going this year, but I have taught a course there a couple of times, and if we could do any kind of more super duper graphics work in VR or whatever, that'd be a nice place to go. So those are kinds of the meetings that we go to. Oh, also, I'll take a... Now, I guess this is going to get recorded and it might end up being online in perpetuity, but at least for now, 2022 and 2023, we're doing winter school in Ascona in Switzerland. So if anybody watches this before then, registration is open, and take a look at ETH Winter School on Eye Tracking. Just Google for that and you'll find it.
Awesome. Who is it for? Is it more for like a I don't know, PhD students who want to get to know more about eye tracking, or if it's for researchers? What are who's going to these meetings?
This one is kind of a one-time thing. We did one in 2016, but it's mainly for PhD students. Yeah. Okay. Anybody who's kind of like maybe starting out wants to know how to do the sort of a typical experiment, that sort of thing. So it'll be me, Krzysz Isa, his wife, Nina Gerer, who was there in 2016 as a student. She's now Dr. Gerer. So
congratulations.
Presenting, to her. Well, she did her PhD in tubing. Yeah. So it'll be kind of how to do an eye tracking experiment using all sorts of tools.
Nice.
And maybe we'll use RealEye as well in there.
Super happy to be part of it. if RealEye is a part of it. About the subtitles, we've seen several different studies and researches about the new type of subtitles appearing on the screen. So one of them was actually we're used to that the subtitles are being presented at the bottom of the screen. We've seen probably in the online Korean school that you also kind of took part some time ago, subtitles which were coming out of the mouth of people who were actually kind of saying things. Do you think there are better way to present the subtitles than on the bottom? And if yes, then
I think
which
the video
method
feed
is
just
winning one,
there,
at least for now?
Or at least it kind of paused on me. So, yeah, we're still doing these kind of basic tests. And subtitling people have been looking at this for many years. What's the better font, better color, transparency, position, speed of subtitles. I know that I just did a little bit of analysis for Agnieszka Sharkovska, and we're looking at the data there. And so they varied speed of subtitles, things like this. So all these things are still being looked at, except I guess it's taken a while to look at it from an eye tracking perspective. So that's what we're doing, and we're doing it in VR on 360 videos.
Okay.
But are there better ways to do subtitles?
Maybe. We'll find out.
Yeah, we'll find
if yes, if yes, then we'll see them on Netflix soon.
Maybe. Well, you need an eye tracker or a webcam to do it. We'll see.
What about the eye tracking in diagnosing diseases in the health sector? Is there anything to be done soon? And do you think is it possible to do with any revolution with the webcam accuracy? We all know that the accuracy of webcam is a bit lower than the hardware, but is there place for some diagnostics?
Yeah. He was kind of a pioneer in eye tracking, and he still does this. A fellow named David Z. And he presented an excellent talk at ETRA at this open EDS kind of sub-conference at ETRA. But he gave kind of a keynote. And he's a neuroscientist, neurologist, I think at Johns Hopkins. And he does this on a regular basis. In other words, by this I mean clinical diagnosis of neurological problems. I don't remember them all by heart. I'd have to read up on it to find out what they were. But as an example, he showed videos of patients where they come in and they say, "Oh, I'm feeling dizzy," right? And so he says, well, he looks at their eyes and they're doing this kind of nystagmus type movement. And with that, he's like, he knows that, given that kind of movement, that means this brain area potentially has a lesion or something in it. So I think there's great potential here. And the tests for eye movements I think are actually really almost too simple to believe, because all you really need is something like a target that does this kind of a thing, just goes in a circle at a fixed rate. And if you can follow it, no problem. And, but if you can't follow it, if you're having this kind of error in your eye movement signal, then there's potential for problems. So there was also at the same talk, there was this woman from RealEye, where they actually sell these kinds of devices, which are embedded eye trackers, but they sell them to ophthalmologists, optometrists, and you go and you put your head in there and you just follow the circle or follow a line. I mean, the stimulus could just be like this, it's like follow my finger, right? I mean, that's what they do at the doctor's office or in sporting events to test for concussion. So the stimulus is almost too easy, too good to be true. But if you put that in there, if you just do a circle that does this or a dot that does this, and then ask your users to follow that, you can potentially get really informative clinical kinds of I can't say diagnoses, because this is the tricky area here, and even in the States here, it's very kind of sticky into how do you get federal drug and what's the FDA stand for, Federal Drug Agency or something, but oftentimes they need FDA approval. Okay. And even then, you can't call it diagnosis, because you can only say something like, well, it's potential problems, go see a doctor. So it's a very difficult kind of area from this legal perspective. American culture is very litigious. If you misdiagnose somebody, you can get sued for malpractice or whatever. So one has to tread very carefully here, but there are several companies that do this already, and RealEye is one of them. Oculogica is another, and so forth. So I think it's a really fertile ground, even though it is kind of a bit of a minefield. So you have to walk carefully there.
Yeah, I'm asking because we had several use cases at RealEye that companies were testing, for instance, kids and their reading patterns. So they're presenting text and checking whether they have reading too fast or skipping words to diagnose different maybe symptoms, not diseases. It's just like you said, it's not going to provide you the results. It's just going to tell you that there might be something wrong with the kid because, I don't know, ADHD or something, because he or she is reading too fast or skipping words. So that was also kind of like we were brainstorming about it several times, whether a webcam approach is going to help out to distribute the ability to diagnose at scale. Yeah.
Yeah, I definitely think so. Reading is another one where I think it's very useful. Yeah, dyslexia or whatever, right? If you're throwing up sentences or something and students having trouble, or they keep regressing or something on a certain word, or they're skipping whatever. Yeah, that would also be, I think, very, very useful and has great potential. Cool. There's also in terms of clinical kinds of things like this. What's the other one where I went to a panel at SFARI. You can look them up. It's this kind of foundation in the States where they are very much interested in autism. And so one of the eye movement related findings was that, signs of autism suggest that with autism, you tend not to make eye contact. You kind of avert your eyes from making eye contact. And so that also is another area where, the stimulus could just be some person talking or showing a toy or something. And if the viewer, the child, for example, is not making eye contact, that could be an indication of something. So
nice.
But again, that's also kind of a difficult area to get into. Fred Schick, who was the general chair for ETRA this year, he's really well versed in that. And so to break ground in that, you really have to be well versed in in various autistic kind of literature and research.
Okay, Andrew, thanks. These were all my questions for today.
Hey, anytime.
If we're going to get popular, we can make a series interviews with Andrew Duchowski. On the next one, I'm going to ask you to drum a bit, if you don't mind.
Okay. I'll bring some props. In my lab, just across the way, I have my eye tracking museum where I have all these old gear sitting there. So if you ever visit us in Clemson, I'll show you all these things. Or next time I'll bring in them.
One day we will, for sure. Awesome.
Yeah. So one of the sort of famous publications was for wavelets was Duchowski's 10 lectures on wavelets. So yeah, we can definitely do Duchowski's 10 interviews if you like.
We will see how the statistics will go.
Whether you get any eye movements on this or
yes, we're going to check the content first, and put
some
honestly,
subtitles on it.
Subtitles for sure. But anyway, thanks a lot for having this interview with us. I think that there's a lot of people who'd like to hear how eye tracking is doing today, and just to hear what's happening, how to get to other people who are into eye tracking world. So thanks again, and
my pleasure.
Have a good day then.
Me.
Thank you.
Thanks a lot. You too.